Hello everyone and welcome back to another tutorial, and this is tutorial number 5, and today we are going to look at the final CDU preflight and takeoff calculation in the 737. So first a disclaimer, I'm not a real world pilot, so everything might not be 100% correct, but it is good enough for a realistic flight inside the simulator. So let me begin. So when you have got the load sheet or that the aircraft is fully loaded, you can go down to FNC to the performance init page. If you click on the button beside the seal fuel weight, you're going to get the current seal fuel weight of the aircraft. Click it one more time and you're going to enter it in, and then you get the gross weight and the center of gravity of the aircraft. When you're happy, you can click on the execute button, and then we can go into the performance calculator. So here we have the performance calculator of in the PMDG universal flight tablet. You have your airport here, you can change it if you want to, but this is correct. Also Gardermoen, you can take the runway, go to the part by on 19 on left. And it's going to insert the heading, elevation and slope and so on, and the runway length. So if you are going to use an intersection departure, you can just click here and you can change the runway, but we are going to use a full length today. You can check if the runway conditions or what runway conditions you are going to use. So currently it's dry. If it is raining or snowing, you're going to use wet. But in these conditions, it is dry. Then we can go down to the aircraft options here. So the flaps. Normally, many airlines flying the 737 are normally using flaps 5. Norwegian as well, so we're going to select flaps 5. If you use flaps 1, when you then rotate at the normal rate, you're going to get a tail clearance of about 33 centimeters above the ground. And that safety margin is going to increase with flaps 5 to about 51 centimeters. And this is in the 737-800. So it's a little bit different from the to the 900 and to the 600. So it depends on the length of the aircraft. But Norwegian normally uses flaps 5, and that's also what I'm normally using. The rating, you can set that to optimum. And you can change it if you want to, but optimum is going to be fine. So then, anti-ice. First we need to discuss what the difference is between engine and wing anti-ice. So the engine anti-ice, that is an anti-icing tool that is used for preventing icing up or build-up of ice on the aircraft. The wing anti-ice is used for de-icing. A little bit confusing on the name, but if you have already accumulated ice on the aircraft, you can turn the wing anti-ice on to try to remove that ice from the aircraft in the air. Not on ground, but in the air. So if the temperatures are below 10 degrees and you have visible precipitation like snow, rain, fog or low visibility, you're going to turn the engine anti-ice on for departure. That is mandatory. And then you're also going to turn on the wing anti-ice before takeoff. The wing anti-ice is going to turn off automatically after or when you are taking off. So you're going to turn all of the 3 on the ground. So if it is, like I said, if it is 10 degrees or below and visible precipitation, we'll use engine anti-ice. And then you're also going to turn on the wing anti-ice on taxi. The engine and wing anti-ice in the performance calculator is used if you know that you're going to use wing anti-ice after takeoff, and you're going to turn it on again. So that is when you are going to use that one. But the weather is good, so we're not going to use any anti-ice. And then you get to the weight, the takeoff weight. That is 67,100 kilograms. And you get the center of gravity. That is going to be 17.8%. And the packs, they should always be on. If the only time you're going to turn that off is performance reasons like short runway and you're heavy. It is very complicated and very safety critical if you're going to take off flaps or packs off takeoff. So it has a lot of procedures in there. So normally it is on, and if it is actually necessary that you need to turn it off, then you're going to do that. But normally it should be on. For the weather, you can import the weather here from the airport. We are flying not with live weather. So we have friendly scatter clouds, so that means the winds are going to be 0, 0, 0. at 0 knots. Temperature is going to be 15 degrees. And the QNH is 1013. There you go. When you're happy, you can click calculate, and that is going to calculate the V-speeds for you. Before we enter everything into the FMC, we're going to go to the landing dispatch. This is something you should do every time before landing or for departure, that you know that you are sure that you can actually land at your destination. So we're going to select the runway again. We expect to the left, and you get all the information again and runway conditions. That is going to be dry. We're going to select the landing flaps. That's going to be 30 for us. We can also change it to 15. That's normally used for a single engine landing, and flaps 40 if you want to reduce the distance. Packs normally as well on, and the anti-ice the same procedures. If it is below 10 degrees and visible precipitation, snow, rain, things like that, you should have them on. And the weather again, flying with the scatter preset, so it's going to do the same. Winds are 0, 0, 0 at 0 knots. Temperature is going to be 15 degrees, and the QNH is going to be 1013. And you're going to click calculate, and then you can see here your expected VREF and the weight of the aircraft. So the maximum landing weight in this aircraft is going to be 66 tons or 66.3 tons, and that is what the landing dispatch have calculated. So that means we can depart or land with our maximum landing weights. So this is something you're always going to do before you depart out of the airport. Going back here to the takeoff, we can then begin to insert it to the FMC. So we can go to the N1 limit here, and we're going to see here we have a takeoff 1 rating and assumed temperature of 33 degrees. So takeoff 1, that's going to be this one. So takeoff 1 in here, and 33 degrees, and that's going to be selected up here. You can see we got a reduced a rating of 92.8. We're going to cross check here, 92.8. So if the difference is between or a 400, so if it said 92.4, it would have been acceptable, or 93.2. But it is greater than 92.8, or sorry, than 0.4. Then you need to check through your calculation to see that you have done everything correctly. And this all depends if you are going to have the bleed on currently, or if you're going to have the bleed on for departure or not. So we'll go to the takeoff. Flaps going to be 5. The center of gravity, if you just click it once, you get the center of gravity of the aircraft. Click it twice, and then you have your trim. And then the V speeds, V1 is going to be 140, rotate 141, and V2 148. So if the V speeds here is within 1 knot from the takeoff calculator, you can use it. So it said 140, 141, that's within 1 knot, you can use that. 140 and 148. But if it is more than 140, oh sorry, 1 knot, then you're always going to use what the takeoff calculator says. That's very important. And there you go, we have now got all the take weights. The only time you should go to the next page here if you're going to change the acceleration altitude. This is normally going to be changed if you're going to use a nose abatement departure number 1 when the acceleration height is going to be 3,000 feet. But normally this is going to be left alone. So there you go, then you have done everything in the takeoff page. And you have calculated your takeoff weight, and you have done the landing dispatch. So that is it for this one, and the next tutorial we're going to cover the push and start procedure. So yes, I hope that you have enjoyed this one, and I hope to see you again on a future live stream. So have a good one, bye bye.